Hello guys, welcome to our geometry lesson. Today's topic is regular polygons. And you will be able to know the definition of regular polygon and its properties, the definitions of inscribed and circumscribed polygons, solve problems related to this topic. Key terms: polygon, regular polygon, equilateral, equiangular, inscribed and circumscribed. Learn these key terms, please. Interesting fact about polygon. Here you can see a pyramid and the four sides are equilateral triangle, yes? And these triangles are regular polygons. And here this building is called pentagon. Pentagon means 5 angle. And here these sides are all equal to each other. Then here this figure is called hexagon. Hexagon means 6 sides. All sides are equal to each other, and this cone has 10 sides. If our figure has 3 sides, it's called triangle. If 4 sides, quadrilateral. If 5, pentagon, and so on. Here 6 hexagon, 7 heptagon, 8 octagon, 9 nonagon, and decagon. Okay, learn these names, okay? Let's start our new lesson. These two figures are equilateral polygon. Equilateral means congruent sides or equal sides. And these figures are equiangular polygons. It means that these figures has congruent interior angles or equal angles. Okay, the definition of a regular polygon is a polygon which is both equilateral and equiangular is regular polygon. Here are the examples of a regular polygon. If you look to the sides and angles, they are all equal to each other. Interior angle measures. We know that the sum of the measures of the interior angles of n side polygon is this formula, yes? And since the interior angles of a regular polygon are all congruent, the measure of one angle is this expression. And here is number of sides. Example number 1. What is the measure of each interior angle of a regular 8-sided polygon or octagon? If we use this formula, okay, here n is number of sides, yes? We know that octagon is 8-sided polygon and we just put to the n 8. If we solve this expression, we have here 135 degrees. It means that each interior angle is equal to 135 degrees. Okay. Exterior angle measures. We know that the sum of the measures of the exterior angles of any polygon is 360 degrees. So the measure of each exterior angle of any regular n-sided polygon is 360 degrees divided by n. n is the number of sides. Example number 2. What's the measure of each exterior angle of a regular hexagon? We know that hexagon has 6 sides. From that, if you use this formula, we just divide 360 by 6. And each exterior angle is equal to 60 degrees. Example number 3. In the figure ABCD, etc. is a regular polygon and the measure of BDE is equal to 120 degrees. How many sides does this polygon have? We know that regular polygon has equal sides. From that, here BCD is an isosceles triangle. From that, angle B is equal to angle D. And we can name this by x. From that, angle D equal to x plus 120 degrees. And we know that regular polygon has equal angles and the angle C is also equal to 120 degrees plus x. After that, look at triangle BCD here. Here we can find easily x because we know that sum of the measures of interior angles of a triangle is equal to 180 degrees. From that, x plus 120 degrees plus x is equal to 180 degrees and x is equal to 20 degrees. And then If we put to the x 20, we will have 140 degree. Each interior angle is equal to 140 degree. And we must find number of sides of this polygon, yes? And to do this, we use this formula here. A is equal to 140 degree interior angle, and if we put here 140 degree, we can easily find n. If we solve this equation step by step here, we will have n is equal to 9. It means that this regular polygon has 9 sides. Okay, next. The polygon is called inscribed polygon or cyclic polygon if all of its vertices lie on the same circle. This circle is called the circumscribed circle or circumcircle of the polygon. Here are the examples of circumscribed circle. Look at these figures. Look at these polygons. A, B, and C are the vertices of this triangle, and these vertices are lying on the circle. Here D, E, F, G are all the vertices of this quadrilateral, and they are lines on the circle. Here is the same. A polygon is called a circumscribed polygon if its sides are all tangent to the same circle. This circle is called the inscribed circle of the polygon. Here are the examples of inscribed circle or circumscribed polygon. All the sides are tangent to the circle. Okay guys, look at these terms, yes? Inscribed polygon means that polygon is in the circle, yes? Or circumscribed circle means that circle is outside of the polygon, okay? Here, circumscribed polygon means that polygon is outside of the circle, or inscribed circle means that circle is in the polygon, okay? Don't forget please. A regular polygon is always an inscribed and circumscribed polygon, and its inscribed and circumscribed circles have the same center. Conversely, if the inscribed and circumscribed circles of a polygon have the same center, then this polygon is a regular polygon. Here are the examples, okay? Look at the first one. Here, blue circle is inscribed circle, and the red circle is circumscribed circle. And they all have same center. From that we can see this triangle is a regular polygon. Okay, next. Example number 4. A square has sides 6 cm long. Find the radii of its inscribed and the circumscribed circles. Look at solution. The centers of the inscribed and circumscribed circles lie at the intersection of the diagonals of the square. Here, AC and BD are diagonals, and the center lies on these diagonals. The radius r of the inscribed circle is the half the length of the side of the square. BC is equal to 6, and the radius will be 6 divided by 2 is equal to 3 centimeters. We found the radius of the inscribed circle. The radius of the circumscribed circle is half the length of the diagonal. AC is a diagonal, and the half of this diagonal is the radius of circumscribed circle. And by Pythagorean theorem, we can easily find AC here. 6 square plus 6 square is equal to AC square, and AC is equal to 6 multiplied by under 2. And if we divide AC by 2, we found radius of circumscribed circle. So the radius of circumscribed circle is equal to 3 multiplied by under 2 centimeters. I think it is clear for you. Example number 5. A regular hexagon has sides of length 8 cm. Find the radii of its inscribed and circumscribed circles. Okay, solution. If you look here, O is the center of inscribed and circumscribed circles. And the OD here, the radius of circumscribed circle, and the OH is the radius of inscribed circle. Here ODE is a isosceles triangle. OD is equal to OE, yes? And then OH is the altitude of this triangle and also the median of this triangle. From that, DH and the HE are equal to each other here. And we know that DOE is a central angle, and we can find this. We divide 360 degree by 6, and it is equal to 60 degree. These angles are equal to each other. From that, 60 divided by 2 is equal to 30 degree. Yes, HOE is equal to 30 degree. And DE, we know that equal to 8 centimeters. And OH is a median. From that, HE will be 8 divided by 2. HE is equal to 4 centimeters. Yes? And then, by using this special triangle, we can easily find radii of inscribed and circumscribed circles. Okay? Here we know that HOE is 30 degree, HOHE is 90 degree, and the HEO will be 60 degree. Yes? And the HE is equal to 4, A is equal to 4, and the OH will be equal to A multiplied by under root 3. We know A, 4 multiplied by under root 3 will be OH, and OH is the radius of inscribed circle. Here OE will be 2A. We know A is equal to 4. 2 multiplied by 4 will be 8. From that, the radius of circumscribed circle will be 8 centimeters. Okay guys, reference for you. You can visit these websites or you can look to your books for additional information. Thank you for watching. See you on the next video. Goodbye.